We get started. My name is Jared DeMott. We're talking about using next-gen fuzzing tools sitting on a pile o day. Yeah, my co-speaker John is down here. He's going to be coming up halfway through to kind of pick up where I leave off. So thank you so much for coming. Really excited to be here as always. Yeah, good stuff. So if you don't know who I am, I'm the founder of VDA Labs, former NSA, built a bunch of next-gen tech, have classes on Pluralsight, in the news, train here, did a training class here, was really fun. Did our advanced memory corruption class here, so we just finished up to that. So any of my students that were in that, anybody here? Did anybody come? I think I saw a few. Oh, nobody wants to admit it. Okay. Anyway, there he is. There's at least one. I know there's a few that were going to come. So cool. So that's me. John, also, he's a senior security engineer with us here at VDA Labs and does a lot of things from penetration testing to code auditing and all the different sort of things that we do, app tests, social engineering. We do a lot of different things, and I won't bore you with a long pitch about what we do at VDA, but just so you have some background, so you know why are these guys even fuzzing for O-Day, and how did they get access to Microsoft's tool? That's another good question, which I won't answer, but well, maybe we will. But basically, we do, that kind of fits into our special projects, so we kind of split our business into sort of for the maker side. So we do a lot of code audits and product tests and IoT and SDLC and training for kind of product maker. And then we also do a lot of the enterprise, red teaming, compliance, monitoring, blue team, security engineering, a lot of really interesting stuff like that. So very exciting stuff for all different industries. And that's us here, Jared and John at VDA. We actually have another talk here. Michael's in the audience. Michael, raise your hand. I'm going to embarrass you. We have at least another talk of some other VDA folks. They're going to be doing a WebSocket hacking talk. If you stick around until Sunday, you'll want to catch that one too, because he's going to be talking about making WebSockets great again. I think that's the hat I saw. I'm pretty sure. I don't know. Did I hear that? Maybe I misheard that. I might have made that up. I could have. It's possible. So one thing when you talk about doing a product security assessment, just to give you a real quick background, I'm not going to bore you with a long, SDLC thing or anything like that, but just to give you a little backdrop on how a product or software security testing, the whole life cycle and process and maturity of software security, it is kind of different from enterprise security. And we work on both, and we see those differences. In spirit, it's kind of similar, right? It's measuring and metrics and training and kind of doing better, kind of continuous improvement. The idea is the same with any sort of security program, but it's a little bit different because you've got to train developers and architecture review and ramp up on the domain, code creation and testing, component, static, dynamic, manual analysis. These are some of the skill sets from at least a penetration testing or a product security assessment skill set that's a little bit different than kind of the enterprise pen testing, vuln scanning, different type of skill set. But kind of, a lot of the same folks, some of the same folks do both. Not all do, though. But so just to give you a little background that there is a little bit of a difference, and that's kind of the background that we come from, which is kind of understanding both. So, and one of the things to take away from this is fuzzing the only way that you could find O-Day, or is fuzzing the only way that you could mature your software product? Of course not. There's lots of different SDLC programs, and there's lots of different places from the design review to the, who knows what type of static analysis tools. A lot of different ways that you could find, and you should use all those techniques to find bugs. We're just talking in particular about next-gen fuzzing. So, and of course, the reason you want to do any of those activities is because it'll cost you more, and this is true of, this is our business case. If you're in security and you haven't, figured out how to make a business case to your manager yet, this is basically how you make the case to your management or your customer, which is if you don't spend money now, you'll spend more later, right? That's the whole reason we do security from a business analysis side of things. And so that's true of software security too, right? It's going to cost you more to fix your products once they're fielded. Now, what kind of bugs are we going to be talking about today that are kind of, mostly we're talking about the tool and the fuzzing and how to use it and how we find bugs and stuff. So, but we do want to give you just a little bit of backdrop because, the type of people that are interested in fully compiled native code, C, C++, assembly, that kind of stuff, it's a slightly different set of folks than maybe are always interested in mobile apps, web apps, lots of different kinds of languages, Rust, Go, more memory-safe languages. By the way, if you can use those, you should. Just putting that out there for what it's worth. Because there are still a lot of memory corruption vulnerabilities still being found. You would think that, in 20 years that I've been in this field and in 20 years that things would have changed drastically. And in some ways they have. And in other ways, I'll show you an example of a vulnerability we just found last night, actually, as we were kind of continuing with some of this research, where we see that, man, this looks a lot like the late 90s. Interesting, you know? So you still see a lot of different, so depending on the language you're working at, you're going to look for a different set of bugs, like OS top 10 for more web apps, memory corruption for more C and C++. So that's just the backdrop there. And again, DAST is one of the ways that you would find dynamic application security testing, which for native code generally means fuzzing. And interesting little bit of trivia here, 70% of the patched CVEs in Windows over the last 20 years are still memory corruption vulnerabilities. That actually hasn't changed. That statistic has not changed over the years. It goes up and down a little bit, you know, year to year, but generally that's the same. And you might say, wow, that's really weird. Like, I would have thought that, you know, overflows and heap overflows and uninitialized memory and all these different kinds of use after freeze, type confusion, all these kind of vulnerabilities, those would all be gone by now. But when you're a platform maker, like Microsoft or like other operating systems or kernels or desktop, if you're Office or making a browser or anything like that, you know, you're writing at that layer where those kind of bugs tend to be prevalent. If you're making a web app in C#, you should have 0% of the bugs that you patch are memory corruption bugs, generally, unless you're working on the .NET framework or something, right? So does that make sense? Just as kind of a backdrop. So what's interesting, though, the tool that we're going to be talking mostly about, which is Microsoft's tool, it's called Microsoft Security Risk Detection Tool. That's the tool that we ultimately decided we wanted to play with most compared to AFL and some of the other next-gen fuzzing tools, and we'll talk more about that. And they've kind of taken this approach of, well, people doing DAST want to also scan web apps, so they've actually included a web app security scanning tool as part of their security scanner. It's not just a native code fuzzer, it also has a web app, which is kind of interesting, kind of more of that suite approach. We see other vendors have taken the same sort of approach, like Synopsys went and bought a whole bunch of companies, and they include a whole bunch of different products across the board in their suite of offerings as well. So not uncommon that we see companies that are playing in security kind of offering not just one niche product, but trying to offer more of a suite of products. So anyway, long story short, there's things that you could test from APIs, input fields, setting, pages, whatever on the website, and of course more of the file inputs or packet inputs or whatever it may be on the native side. If you're testing a web server, you're sending data to it via packets. If it's more like Office, you're delivering more like Office documents to it. So somehow we need to get data to it and see if the application can be robust in the face of kind of severe inputs or mutated inputs or you know, kind of as you get code coverage across the app. So I'll talk more and explain more about that. Last little bit of background is that there are pros and cons to different approaches, right? The manual, you know, security analysis approaches, they find those hard to find bugs. Dynamic finds bugs in like heavy parsing code where reading it's hard or static analysis might fail. And it tends to get less false positives, which is great in dynamic. Although it's not perfect either, right? It doesn't, you know, it only is hitting certain parts of the app, generally speaking. In the past, one of the biggest, you know, sort of criticisms of fuzzing was, well, it doesn't integrate well with CI/CD, so we only use it kind of ad hoc now and then, and it's really only hitting the attack surface, so we're not going very deep in the protocol. And so static analysis is better generally because we can run that, you know, maybe every time we check in code, or we have a better ability to integrate static analysis into CI/CD. So that's kind of been the best tool maybe in some ways from a security standpoint, from a developer standpoint. But yeah, fuzzing finds a lot of bugs, and so does manual analysis, and it's like you need those. You really need those approaches in there too. And so that's kind of what we're going to be talking about too, which is how do we integrate these in a more continuous manner so that we can do this better than just an ad hoc basis. So that's part of what we want to get across. So that's the background on kind of, you know, software security in general, and kind of who we are and why we're doing this project. Why we're doing this project because I've been interested in fuzzing my whole career, and it's a very interesting way that we can get back to the community, sharing the research and stuff that we do. And I think there's a lot of need. There's a lot of companies that still are not integrating fuzzing into their development lifecycle, and there's a lot of hackers, you know, maybe still not realizing they can fully leverage next-gen fuzzing into bug hunting. So whichever side, whether you're kind of more on the offense or defense, you can take kind of what we're going to release some of this on a GitHub too, some of the stuff that we're going to talk about. So. All right, real quickly, and it'll be quick, I promise, because maybe if you followed fuzzing, you kind of know some of the traditional fuzzing tools versus feedback, which is what we're going to be talking about. So traditional fuzzing methods are mutation, and basically that would be like you have a bunch of samples, a bunch of whatever files, whatever you're fuzzing, right? Could be images, could be movies, could be PNGs, could be PDFs, could be whatever. If you're doing file fuzzing, we're using file fuzzing in this case mostly because they integrate the easiest into feedback fuzzers, and I'll talk about why that is. So you have a bunch of samples. Maybe you do some min set to get good seeds and all that. John will talk a little bit about seeds, but basically you need long run times because it's not very intelligently targeted fuzzing. So that's one good and bad. So it's not overly complex to set up, but it's not. Could take a long time to get good code coverage across the app if you're doing mutation fuzzing. Generation fuzzing was more where you construct the inputs from scratch. So you sort of reverse engineer maybe the RFC, or you read through it and you basically say this field does this, these 3 bytes do this, here's a hash, here's a field, here's a length, here's do. You kind of reconstruct the protocol, whether it's network or file or whatever, and then you generate inputs, deliver it to the application, and then boom, maybe you find your bug there. You hope so. That's the whole idea. You're monitoring throughout that process. If you're not monitoring, you're wasting your time, right? So it's a little bit laborious, though, to create those data definitions. I don't know if anybody's done that with like peach pits or any of the kind of fuzzers that are out there, things like that. It's really cool and a really good way to get going fuzzing stuff. Still a very valid way. Create a Sully definition, or BooFuzz is the newer port of Sully. But it's a little bit laborious to create those. And that's kind of the downside there. There are some tools that you can buy, like Defense6. So it was a company called Derbycon, got bought by Synopsys. Now it's called Defense6. And they basically have a suite of existing, like you can buy their JPEG fuzzer, their Bluetooth fuzzer, their IPv6 fuzzer, whatever it is. So you can and that's another approach. So these were the 3 primary approaches really before feedback fuzzing came to be. So things this is a tool that I wrote a long time ago called General Purpose Fuzzer, Spike, The Art of Fuzzing, Mini Fuzz, BFF, Radma, Sully, BooFuzz, Kernel Fuzz, Peach Fuzzer, Defense6. These are a lot of existing tools that are out there that you can either go and download or buy or whatever, and they all work pretty good. Generally speaking, they've all found their fair share of significant vulnerabilities and bugs in the past. So good stuff there. That's kind of the roots and the history of fuzzing. And then I actually, as part of my PhD work, I actually started doing some research into new fuzzing techniques, and other people did too. Things like scale and feedback being one of the more interesting ones, using either a genetic algorithm or a constraint solver to find and automatically generate new inputs so that you don't have to either fuzz forever with mutation or take this laborious task of creating a fuzzing definition. So that's the whole idea with feedback. That's why it's cool. My early research was called CyberFuzz. I originally called it Cluster Fuzz, which interestingly enough, Google came out with something called Cluster Fuzz too, which is really interesting. My advisor made me change mine to CyberFuzz because he thought Cluster Fuzz sounded too, bad or something, I guess. But anyway, ultimately though, what the 2 tools that really emerged from all the early research from different people was Sage and AFL. Sage was a Microsoft internal tool. AFL is a public, free, open source tool that came out of kind of the Google vein of things. And those 2 tools are really the 2, I think, best fuzzers out there that people should be using in one fashion or another. If you're interested in doing fuzzing and all, those are really where you want to be. And so from the AFL side of things, from the Google side of the house, you've got AFL itself. That black screenshot is a screenshot of AFL. And there's a bunch of tools that are now trying to commercialize AFL. There's one called FuzzBuzz and one called Fuzzit and a bunch of others. I think Google just has a free and open source one called Cluster Fuzz. You can just use that. So, and the idea and the benefit of those is you get the power of feedback fuzzing, and you should apply it at scale through the cloud or something like that so that you can get this massive horsepower, and you can find these hard-to-reach bugs, right? That's the idea, is there's going to be in any significant, especially old, complex code base, think of things like font files or JavaScript engines or image rendering, movie rendering, even simple Unix utilities. Like, could LS have a vulnerability? You wonder. I don't know. It's weird. We'll talk about that. Or simple utilities like that. You wouldn't think so, right? Some of them you think that there shouldn't really be vulnerabilities there. But anyway, bugs tend to hide for one of 3 reasons. Either the code is old and complex and kind of hard to find bugs in, or there's just a very hard to reach. This is an example of kind of a theoretical, it's not a real piece of code, but this theoretical bug is what drove the research behind Sage and AFL. Like, if you had some bug that was hard to reach because you have to input exactly the right parameters, and if and only if you do that will you trigger this bug, those are considered sort of hard to reach, right? So your mutation fuzzer might have to run forever to find that, or a long time. And so that was really what drove the need. And Sage went down the route of constraint solving, which is like, okay, if I don't match this if loop, then I'll negate each constraint until we finally follow all the paths through this. So the constraint solving theoretically is the best way to do it. AFL took more the genetic algorithm route, which is, well, we've got some good samples, and we're just going to kind of search through this by kind of percolating and mating and mutating data, but in it with a GA. And eventually either one should get to this is sort of the hope and the idea, as well as applying fuzzing best practice. So you got this great fuzzing library, kind of known heuristics of fuzzy inputs in the past that have caused things. So kind of not just randomly changing things, but with some intelligence as well. So that's kind of some of the background of why there was a need for constraint solving and other types of search feedback fuzzers. And they have borne fruit, okay? And this is another sort of old background from the original Microsoft Research Sage paper that shows some of the tools like App Verifier, Nirvana, TrueScan, Z3, Constraint Solver. Basically the process of test an input. If it doesn't cause a crash, let's make some new inputs and try some more, in some way or another. We'll make new inputs. So we're sort of, in some ways, creating the test suite, kind of as we run. And that's really cool. And, there's been a lot of fruit that's come out of that. Microsoft said way back when they were doing the file fuzzing for Windows 7, that Sage found a third of all the file fuzzing bugs after they'd run all their other tools. So it's a very significant amount of findings that they have with Sage. But it was very private, very internal tool to Microsoft. It wasn't something that they wanted to release to the public, understandably, because it's like, hey, we've got this O-Day machine that we're using to find a bunch of flaws in our own software. We probably shouldn't give that to the world. Like, that seems like a bad idea. But then they later decided that they would do that. And so they came up with a project called Springfield. That was the early name for it. And now there's a tool called Microsoft Security Research, or MSRD, where commercially you can buy, or if you have a Microsoft license already, you can get access to this product. And that's really cool. That's really interesting. And that's something that we wanted to take a look at and be a part of. So we got involved in that, asked the primary manager of that, David Molnar, if we could get involved in that. And he's like, sure, yeah, here's access to MSRD, fuzz away. So that's kind of cool. That's basically how we got access to MSRD, which is really interesting and very fun for us to be able to have a chance to find some interesting bugs. Now, of course, constraint solvers aren't perfect, right? We see some possible limitations here. There's things like path explosion and non-determinism and hard to solve branches that maybe can't be solved in a straightforward way by a constraint solver. So it's not to say that this tool is going to be the magic machine that finally, like, you put in binary outcomes working exploit or something. It's not quite that magic, right? People have been looking for that, the holy grail of sort of exploit dev, for a long, long time. That's not really a thing. That doesn't really exist. But, some tools are better than others in terms of finding at least good crashes, and this is definitely one of them. But what's interesting is that those limitations, those sort of theoretical limitations, aren't actually what's limited fuzzing. I think mostly what's limited fuzzing is still there's a lot of people not applying it to their projects because of what I mentioned earlier. It's been difficult to integrate fuzzing in a reliable way to your project. It's been you needed a very skilled individual to write a fuzzer and to apply it and to use it. And so that's been kind of the thing that I think's limited fuzzing the most, more than anything. And so that's one of the things that Cluster Fuzz with AFL and MSRD with Azure DevOps, they're changing that. There's a way now that you can actually apply fuzzing in an ongoing, straightforward way into your DevOps lifecycle, which is really cool. So that's something that, that's one of the takeaways I want you to know about this, is that you can actually integrate MSRD into your product in an ongoing kind of manner. So Microsoft Security Research Detection, that's all the background on us and fuzzing and all that stuff. So what about this tool? Tell me more about this interesting tool that you're talking about. So here's the website, Microsoft Security Risk Detection. You can go and check that out and kind of learn more about that. Scalable, cloud-based, easy to set up, a targeted application. It does a lot of the little things that help you find bugs anyway. Things like enabling the debug heap and a lot of these little tricks that expert fuzzers kind of knew about, but a lot of other people didn't know about. They're all sort of already integrated into the fuzzing environment, which is really cool. Nice, web-based graphical reporting. Triaging is made easier. I'm not going to say it's simple. It's still not perfect because you still have to do a lot of the if you want to do any triaging of crashes or, like a lot of it's made simplified because it's bucketed and it's great and you've got the reproduction, you've got the input that caused the crash, all this kind of stuff, really cool stuff you'll see. But you still have to do there is still some expert analysis required. So, and what's cool about it is it finds security bugs in heavily tested apps. So you take an app, like a well-known PDF reader or something like that or whatever, and you throw this at it, and it'll probably find bugs if it hasn't been used against it before. So basically, in our mind, for what we're seeing, it's basically an O-Day machine. That's kind of the bottom line on that. You can find bugs and stuff that has probably been somewhat well tested already. You could probably find new bugs in that. It's pretty cool. That's very interesting to us. So here's a picture of the web scanning portion of MSRD. We're not really going to talk about that in this talk because this talk is more focused on the native and that side of things, the memory corruption and that sort of thing. But if you want to play more with the web scanning tool that's included in MSRD, definitely encourage you to play more about that. We could talk to you more about that kind of offline if you want to hear more about that. And maybe in the future they'll even maybe decide to include like a mobile app scanner or more things yet that would be kind of further arrows in the quiver, so to speak. But right now, it's basically just a native code fuzzer and a web security scanning tool. So that's cool. So this is what the platform looks like. And there are actual O-days, by the way, in this talk that are going to be disclosed. Like some of the application names you're seeing on there, these are actual application names that we're finding vulnerabilities in pretty easily. Like it's not taking us a lot of effort to find real and serious vulnerabilities in some of these applications, which is kind of cool. So we're having a lot of fun blowing up apps. One of the ones that I was just mentioning is interesting because you would think it's a Microsoft tool, you can only fuzz Windows. Actually not true. We're doing a lot of fuzzing for Windows apps in, on a Windows sort of a VM basically as part of the fuzzing. But you can also start Linux fuzzing runs as well, which is really cool. So we've been doing that. So there's a Debian utility called ISOinfo. It's just kind of like a command line utility. I think of it as just kind of like another LS, right? It's just a Unix command. Like, what's the chance that you take the latest version of some random Unix command, throw it in here, and find a vulnerability? Seems unlikely, right? Like, these are well-tested code that's been around forever. You're not going to find a vulnerability. Or actually, yes, you will. Like, I think it took us like, 20 minutes or something to shake out exploitable stack buffer overflows in this. And it's really funny, kind of interesting. This is a screenshot of this actual O-day. So sorry, because this is the portion of Ghidra where you can see the highlighted function is the function that has the vulnerabilities in it. If you're interested in, you don't actually have to reverse this code because it's open source code, right? It's Linux code. So you can go and get the source code and look at it. But the only reason you might need to reverse engineer it is because it crashes in a really weird place that's not directly, the back trace is all messed up. So you kind of have to figure out, it looks like it's crashing at this byte. So I need to actually figure out like in a disassembly where it's crashing so I can make sense of in the source code where the vulnerability really is. So anyway, just, we'll kind of, as we're talking, throw out some O-day just sort of here and there, kind of toss them out a little left and right, why not? So how does MSRD actually work, basically, is one of the things, the thing that we really want to get across, the point that we're trying to make here. So either manually or from a DevOps standpoint, upload your binary, set up the fuzzing run by, you basically, there's a GUI wizard, you answer some questions about what kind of input it takes. The one downer about feedback fuzzers right now is that AFLR and MSRD, they basically depend on the generic format of your application being application file input or maybe some parameters in a file input. They're natively not so great with like network apps or IoT or WebSockets, or they don't do any of that by default. You can actually make these type of fuzzers do that, but it takes some professional services. You basically have to write harnesses and things like that. You need to do some extra work around that to integrate the feedback from those processes. So that's part of what we need. So we're the fuzzing experts on this, and we've been playing with this, and it's been a lot of fun. So you can get multiple fuzzing jobs running, fix, rinse, and repeat. So anyway, that's all my background, and what I'm going to do is turn it over to John, and he's actually going to give a demo walkthrough of how to set up a fuzz run and talk through more of the findings and things that we found.
Awesome. Good job. Hey guys, how we doing? I'm John Steigerwalt. I work at VDA Labs with Jared here as a senior security engineer. So I'm going to walk you through what a demo of MSRD looks like, taking seeds and finding a crash. So here we're going to start off with a demo here. We created this demo. So there's other documentation out there on Microsoft's website, but we decided to do a nice little demo here. So we're basically going to start a job, and this is just remoting to a VM. Like we're just going to provision it real quick. There's more options as well, but we're just using 2008 as just in this demo. So after I created the job here, what happens is it's going to provision it, and it will take some time, especially with Windows. It could be like an hour or two setup. Once that's done, you can just remote into the VM, and you can install any application you want, put your seeds on there, and start a job. Yeah. Oh. Let's skip real quick. Maybe I won't pause it. It's going to die on me. Okay, so we're going to remote to the VM here. So here all it is just it's a 14-day setup. We have 14 days to complete our fuzzing, and that's after submission. So that's really important. Roughly, we get about 3 million fuzzing mutations in those 14 days, and that's on a good job. So, and that's like usually about a 5-second iteration, and they'll do parallel jobs between the fuzzing. So, for example, like if your executable can be renamed, they'll fuzz it simultaneously together. Like it will be a really fast fuzz. If you can't do that, like for a browser where you can't rename Firefox, or like Chrome, which doesn't allow you to do that, you can't do that. So like you're slowed down to probably a few 100,000. So a few 100,000 compared to 3 million, it's pretty good. So here I'm just drop the application on here. I have XNView, which is an example here. All it is just test file, which will be the seeds. I have the seeds in there. I'm doing a WebP file, so I'm just attaching that. So then we have these new options here. Basically, seeds can reference other seeds or reference other files in the web. This will lose internet connection once it does start fuzzing. So it will not, like you can't have it call out to HTML. It's kind of a bummer, but they're working on that. So basically, we'll force it to close, and then we'll validate our job. And this is really important here as well. So if it doesn't validate and you give it like a bad input or a bad crash, it won't let you continue. So you have to give it good data. There's a few ways you can trick it to get it to take bad data, but you can't have a crash. You can have first chance exceptions, but no second chance exceptions, and that's really important. So here we're just going to validate. It was just a 5-second job, so it will take some time. So application verifier is ran with this in the background, and that's what allows us to find the first chance exceptions. And this is where we get our good results from. So here I'm done, submit the job, and then we're going to go ahead and provision it. So then it will take some time to validate that, and we should see that here in this demo. So once we hit validate and submit there, the VM dies, it was internet, and it will start fuzzing. They have their internal communications where you can then see the reporting. So here I'm showing it's validating, and then the results. So here, I ran a job similar to this through XNView. It was FPX. And basically, I found 103, 108 results. And these are all crashes. Divide by zeros, write, read access violations, you name it, null difference pointers. I mean, look at the results. I mean, it's just crazy what you get off it. And that's just one job. I mean, we've run thousands of crashes, lots of O days. So, and right here, I'm showing you a call stack example here. I mean, you saw the corrupted stack, So they have this logging here on there as well, and it takes the WinDBG output, it dumps it. So it's useful, it can be. Sometimes it gives you weird results as well. So I'm showing you a first chance exception here on the stack trace, and then I'm going to go down and show you a second chance exception, and then I'm going to show you a dirty call stack here. Probably on another crash I'm going to show you. Yeah, and this actually did turn out to be an actual O day here. I created an exploit for this one on one of these crashes. I mean, there's so many to choose from right there. So we got a heap, you know, C0, C0, C0. So we landed right in the heap there on an address. So, and that's just one example. I mean, there's so many, and that's just one application. I mean, we've done tons of applications. I've done many, and I'll show you what I've done. There's some big names out there we've definitely targeted. So here in this demo as well, I'm going to show you how to download and test. So you can get the results. They store 10 at a time. There's no way to increase that. So if you have 10 similar crashes that land in the similar call stack, they'll save those 10 for you, and then that's maxed out. So you could download all 10 at one time in a zip file. That's what we're seeing right here. So then once you get the seeds right away that caused the crash, and then sometimes I'll compare them, like we were doing the compare with Ghidra and stuff like that. I'll compare them with 0, 1, 0. So it's pretty easy. So you just pull them over. I have WinDBG up. I'm going to show you what a crash looks like. So I mean, it's so simple to use. So here we're just going to target the application. We've all seen this. So, and then debug for child processes, and then we're going to go ahead and run the application. And there's our first access violation, 0.5 right there, second chance. So we pulled down a crash, just as an example. And that's it. That's it for the demo there. So our results now. So what have we been doing? Why have we been doing this? What are we targeting here? So some of our sample applications, Foxit, PDF Reader, WinZip, WinRAR, Chrome, OpenOffice, LibreOffice. So we had a really cool Office plugin 0-day as well, WPS, iframe view. And I'm going to release one of these here as an O-day later in this demo here. So, and we do lots more as well. We do tons more. So that's just some examples. On here, the screen wasn't big enough to fit them all. So types of crashes we're going to find. So this is really important. Basically, you think everybody's just going to see a read and write access violation. There's more than that. They're adding more and more all the time. It's really great. So we'll see null differences, heap stack corruptions. We saw the Linux example that Jared showed. We saw actually a stack-based overflow right there on the spot. That was really cool. It shows you that. It's really great. We see a lot of divide by zeros. So a lot of these aren't exploitable. But a lot are though, right? So then it depends what your kind of focus is going to be on using the application or MSRD, right? What you're targeting. What are you trying to get out of it? And I'll talk about seeds as well and how important it is and what type of input you're going to send to it. So here's an example results. So Fox updated to update 95, and it broke my my 0-day. So I was like, okay, well, we need another one. So we threw it up there, put some more seeds in there, and I couldn't even fit them all on the screen to show you guys. So all these were all read access violations. We got rights as well. So it was really good stuff. And most of these are exploitable as well. I only wanted to show the exploitable ones here. So we also support Linux fuzzing as well. Obviously, we did the ISO info as well. That was a fun 15-minute setup. It was really good. So it's based on Red Hat Linux. All they do is allow you to SSH into it. You download your programs. GUI is supported as well. It's not too hard to use, and basically they have a free trial right now that anybody can use. So if you want to go out there and start Linux fuzzing and try it, we had results in 25 minutes. I put 25 because was able to calculate the time, but it was less than that. It was like 15 minutes. Once the job started running, ISO info was busted. We checked it, stack buffer overflow, and it's exploitable. So here I'm going to show you an example of crash. So I like to bring this up here. It's really easy to get the results and bring them down. And I tried to highlight that in the demo. I like to highlight it again here. So basically, it's a cloud interface. You have internet access. You get up to the cloud. After you started your fuzzing job, you can run for 14 days. You can stop it. You can run for a day if you want to. You can switch it, interchange out, whatever you want. It's based on how many jobs you have with MSRD. So, and it's based on the seed that you use as well. So if an input seed isn't getting crashes, you stop the job, change the seed input, and you start again. And then you try to get more crashes. It's all based on how creative you can be with it, right? So, and it's really easy to download the files, the results. So we saw the zip file of 10. You can download many, many different kinds of crashes. Different call stacks come out. So, and it's not too bad. After the point of the crash is where I go in and I create the exploit, the 0-day, however you want to call it. But that's still a manual process. There's no way to fully automate that today. So here's our stats so far that I've pulled over. So I started fuzzing with this tool in February, January maybe less than that. So over 50 applications tested. So I went through 15 to 20% are exploitable. So 20 to 25% are probably exploitable. And it all depends on time. And then the 10 to 15 were just come up as unknown. So it could be just weird crashes that happen. It could be the C++ crashes. And then we have the 55 to 60% also unknown as well. So, and this was done with hashbank exploitable just to do a demo. We see a lot of people do that. I figured it'd be kind of cool to throw it in there. So why not? So 1,000 solid bugs, at least 100 O-days so far. So and here is so I'm going to release a 0-day for iframe view. So, and all we're going to do is just pop calculator, but it's a good demo. So right here I'm just going to call it, I already have my POC ready to go. So this is just a real live crash. Very similar to XNView. It's a very popular application. So 32-bit one here, 64-bit was also as well. So, and woo, there goes the pops calculator. So pretty cool. So we're going to release some of our work on GitHub as well. So. Thanks, guys. Appreciate that. So we'll release some of our work on GitHub as well. I like to give back to the community. I think it's really important. Share what we've learned, and help other people fuzz as well. I know when I started, it wasn't as easy to get into and understand seeds. So we're always here to help as well. So that's the biggest thing, and I like to highlight that. It is complex. It can be. Anybody can, download it and start the applications, pull up MSRD, start fuzzing, but to get something really useful, it will take time and practice. So, and especially in the seed discovery and creation, that's one of the hardest parts that I come across. What file formats to use, how to create the file formats, how complex do we have to make it? Do we need to read the protocol and with the specification, like for ISO or WinRAR, like how deep do we really have to go to get viable crashes? So, and that's always really difficult to kind of get to. So the feedback is always good, right? Good tools work, consuming applications. So one thing that I have noticed over some certain applications, MSRD is not always plug and play. So custom harnesses have to be built for certain APIs. Like we did a custom harness for a DL, and I'll show that here later. You may have to be creative and think out of the box with certain things, certain applications. Like it's not like you can't just, if you're trying to fuzz a GUI, for example, and you have to be able to reach that code path to get viable crashes. So if you can't just get on the command line, point to it, it's like, okay, I'm going to get a crash. It doesn't always work that way. If it doesn't work, we go back, we refigure it out, and then we'll try to get to that code path where we want. That's going to get us a good crash that can be exploitable. So we also do software fixes with vendors, and obviously I do the exploit creation as well. So it's really important, responsible disclosure or however you want to word it, but we try to do it the best we can as well. We definitely talk with vendors. We work with the development teams. We release the bugs. We let them know what we found. There's been times where they have no idea what we're talking about, but we keep working with them, and I think that's a good important thing to highlight as well. So we are the MSRD partner. So I'm going to highlight seeds here as well. So good seeds get the best code coverage, and that's really important as well. So like I've gone on where I've downloaded seeds from PDFs off the internet, Google dorking. I pulled them in from Russian websites. You name it, I've done it. So it's really important to have a good seed to have good code coverage. A PDF that just does one thing or has one image, is not as good as a PDF that has 30 images that pulls on different formats, different object files. So it's really important. So good seeds find more crashes, which is true. So I've learned that the hard way. So a fuzzing harness. So this is really important. I like this. So basically, you take inputs. So for example, if you have an application that only talks on the command line, like through an echo or a stin, or basically it can't take a file input. You use your harness to send that to the stin, right? So you'll basically, it's a wrapper. You'll wrap around it and take that file, because MSRD is only file-based input, right? You have to use files, and they mutate those files in that seeds directory. So you have to be creative and take those seeds and send it to your application that way. But the hardest part, though, is getting the crashes back. Like we can create a Perl script right now that would just send input, pipe it over, however you want to do it. Doesn't matter. There's 100 ways you can do it. But getting the crashes back is hard. So you have to include APIs in your harness as well to be able to pull those crashes back. It has to interface with WinDBG, and that's the hardest thing because it's not really documented. Because we're we're in the unknown, in the black area. We're kind of just learning on our own because Microsoft is like, yeah, figure it out. It's cool. Go for it. So harnesses have been known to find old bugs. So they had an Adobe back then, and they used a harness, and they found a really old code path that was a really, really old one. So I thought that was really interesting, and we kind of base our work on that kind of mythology, that idea. So I like that. So here's an example of a custom fuzzing harness we created. Michael in the crowd actually worked on this one here. So this goes credit to him. So basically we're passing data to the DL using seed files. That's all we're doing. So we created basically a vulnerable DL, and then basically we put it in the MSRD, and it found the crash. So the call stack was kind of weird, but it does work. So this is one example. I've done a whole bunch of ones like where I'm doing like ping, or I'm doing Perl wrappers, just using the API to grab the crashes back. But you could use whatever language you want as long as it can be an EXE. You can use any kind of wrapper, so it works. So client-server setups, GUI applications, API testing, which is one of my favorites, and then honestly just a wrapper for whatever you want. You can name it. It could be GUI. I use like auto-it, where I send the GUI up to a certain point in the GUI application, and then I just have MSRD fuzz that kind of seed. But getting the crashes back is the hardest part, though. You can automate anything. It's just getting data, getting results back. So exploit development. This is my favorite part. So I love building exploits. This is what I do. I'll take the crashes and I'll build any kind of exploit if I can, right? But not all of them are exploitable. So we work with vendors, and it's really important to be responsible with what you do and how you build your exploits, right? So sometimes you have to build an exploit, though, to prove the crash is viable, right? It's like, okay, it's just a crash. Well, who cares, right? Well, if I can exploit that program, I can get root, or I can get, system. Doesn't really matter, right? It's important. It is. And some vendors need that. Some vendors need that push, right? So help expedite the fix, which is important. So here I just showing you guys, EIP overflow, 4 A's, 4.1, 4.1, 4.1, and 4.1, it's cool. So, but yeah, exploit development. So it's where the area I like. So code patches. This is really good. So we work with vendors to have them patch the code directly. So sometimes it's difficult, sometimes it's streamless, right? Create a CVE, put it on reserve, wait till the vendor reaches out back to you. Okay, it's good. Okay, release our work then. So, but sometimes they don't understand, they can't do it. So we'll build the patches in IDER or Github, right? Fixing the vulnerable code for them. Jared went over there and showed you the ISO info. We could have patched that right there on the spot. So wasn't too bad. And sometimes it's necessary, but sometimes the application is so weak or so unknown, it's just, is it really worth it? So that's kind of the question. So here I took his screenshot of IDA last night, and he was showing part of the vulnerable code, and then I was showing like how to patch it. So just a good example here, identifying the crash, applying patches to test applications. So, and VDA is going to get back. So we're going to put some of our exploits and crashes on GitHub. So we're going to release some of our work, and we're going to help the community. So I think that's important. That's one thing I like to live and strive by. So, yep, and that's our GitHub. GitHub at VDA Labs, VDA-Labs. So pretty cool. So questions? Come on, Jared.
Great job, John. This is John's first Derbycon talk, so please give him a round of applause. Yeah. Woo. Nice job. Nice job, man. Good work. Good. Yeah, that's awesome. Yeah, no, you can leave it. That's fine. So, yeah, who's got questions for us? Yeah, go ahead.
Is Bang exploitable on the Microsoft side if you have to download the seeds and run it locally?
You want to answer that?
Yeah, I'll answer that. So Bang exploitable is dead, right? From my understanding. No, but someone online has a very good recompiled version of it. I was able to find that. I was able to download it and use it. So, but if you go to the Microsoft website and try to download it, it's not there anymore. So, unfortunately, but it's still a good tool. I like to use it. It's great to show it in the slides, right? So, I mean, does it really tell you a lot? I mean, depends. Using the -m option, sure. But other than that, I mean, yeah. So, anything else? Yes. You have to download the seeds from MSRD, bring them down, and then you have to point to the seeds.
Yeah, one cool thing, though, they do a pretty good job of bucketing the crashes. When you look through the GUI, they'll tell you, like, it looks severe, it's a Stack Overflow. I mean, they do some of that bucketing for you. And yeah, to his point, Bang exploitable was always sort of, kind of a roll of the dice on how accurate it really was. Because a lot of times you might crash over here and it looks like only this, but if you just tweak a few things, all of a sudden now it's more interesting. So, but, it is good. We did some rough bucketing, too, with it and stuff. So, yeah, question? Yeah, it's a good question. I'll take a first stab, and then I'll let you fill in whatever you want to say. But first question is related to... No, I just lost it. Code coverage, right, yes. Yeah, I got distracted asking. Code coverage, so the constraint solver is basically what does the code coverage in MSRD, right? So there's a constraint solving process where it's like, okay, we got to here by either looking at the basic blocks or whatever, and now we need to try to go down these different paths. So in the cage of Sage MSRD, it uses a constraint solver, and I showed that one picture that's showing the 4 different major pieces of tools that it uses to accomplish that. There's a number of different tools that work in conjunction to basically create the new inputs. And then the second question was related to how does it identify whether it was a stack smash or heap smash or that kind of stuff. That's a good question. I don't know if I know all of those, but a lot of times the debugger can report a lot of that anyway. It's going to report through some, like if there's for example, some of the ones we were looking at on the Linux side, there's like a fortify stack check. So some of that's getting bubbled up through an abort. There's a signal that's being thrown anyway. So basically you get that information and they're just kind of bubbling that up to the GUI. And same thing on the Windows side, based on the type of crash they see, they're able to kind of expose that and bubble that up. So I don't know if you want to add to that, but.
So basically, all it used to be was just write and read access violations. They were just labeled all the same, both sides, right? So now they've kind of changed it where they're telling us more information about our crashes. They're trying to make it easier for you guys, right? So for instead of us, like where we have to download the seeds, it's like, okay, what truly is this bug, But now they're trying to help you label it. So they're not always right. They're not. But most of the time, they're trying to get to that point. So, yeah. Okay. Any other questions? Yes. So they have a lot of huge enterprise, no-name kind of clients that work with this tool as well. So there's also the Azure DevOps as well they work with. I'm sorry, what's that? Oh, so he's asking about confidentiality for clients as well. So that's really important, right? So Microsoft has 3-letter code names, or 3-letter companies that we can't really talk about, right, with kind of the confidentiality. all internet connection to the fuzzing once results come are turned off to that VM. So you can change passwords and they recommend, and they'll help you through everything as well with that confidentiality. There's a lot you can do that we don't do. Obviously, we don't really, I mean, it's not really that important to us about our results because we don't have any clients that need that confidentiality for our testing. And we're just doing testing purposes right now with the results we've shown you. So there's a lot more to it that I don't even understand what Microsoft can do with those clients. If you give them a constraint, they'll probably fix it for you.
Yeah, sort of tack onto that too. If you really like, if you're like, man, I'd really like an on-prem version of this instead of running it in their cloud, they might be able to do that. I don't know. That would be a David Molnar question at Microsoft. We could probably bubble that question up to him if you want to reach out to us, info@VDA Labs or jdemont at VDA Labs or whatever. We could probably help you get that question answered. That is a good question, though. Any other questions about MSRD and fuzzing? All right, thank you. Appreciate it, guys.